Starting with tracing, this wing is misoriented, so our number begins at 1. Next, the white and green, we can do an x2 while looking for it. It goes here. This is good, so our number is now 2. Yellow and red goes here. This is good, so our number is now 3. This wing goes here. Good, so it's 4. Green and orange here. Now it's 5 because this is good. Red and white goes here. 6. Yellow and orange goes here. 7. White and orange goes here. Bad, still 7. Yellow and blue goes here. Bad, still 7. Yellow and green goes here. It's bad, so it's still 7. Red and blue goes here. It's bad, so it's still 7. Orange and white goes here. It's bad, so it's still 7. And then this wing returns to our original spot, so we add nothing. That means our final number is 7, and our parity state is odd. Starting to solve, this white center is pretty easy. So I'm probably going to start with that. We can solve the white with 3, which is going to leave it even. So we go trigger like this, then 1. And now, since we have even, this yellow can just be solved using an even number, 1, 2, 3, 4. This doesn't change it. White and blue can be solved using double move. That doesn't change it. White and orange can be solved using a double move. And now we solve this blue center using an even number of inner slice moves. So we can set it up like that and go 1, 2. Now we will not get parity. Continuing, we can solve orange there, solve this orange. Next, solve the green center. And then solve this white and green edge. Now we can slice either way because either way will pair up an edge. I'd probably end up slicing this way and then solve the blue and red here. So I can just take it out, rotate, put it in the back. I don't see any blue or orange anywhere here, so I know it's right here. So I'm going to slice back, put a random edge in, slice this way. That one was green-red, so then I'm going to rotate and put this one in the back here, like this. Now, if you do your final slice move, you're going to end up with a 2-2 cycle case. But I noticed that this one was solved and this one was here. So I can just put one in, slice, cancel into this 3 cycle like that. Next, I saw this pair, probably just do that. This green and orange is pretty easy on the left. Blue and orange, again on the left. And blue and red like this. We did not get parity. And we can do our OLL and our POL. Starting with tracing, we can look at this wing, orange and green. Since it is bad, our number begins at 1. Green and white is here, so it's 2 because it's good. Yellow and red is back here, it's bad, so our number is now still 2. White and red is down here, so our number is now 3 because it's good. And we can recognize here that all of the edges on the left side of the cube have been already traced through, which means every untraced edge is somewhere on the right side of the cube. The yellow and orange goes here. That is 4 because it's good. Blue and red goes here. That is 5 because it's good. Blue and orange is here. It's bad, so it's still 5. Orange and green comes back to our starting position, so we don't edit anything. Starting a second cycle, we can pick orange and white. 6. This goes here. This is bad, so we don't add anything. Yellow and green goes here. It's bad, so it's still 6. We have a third cycle to do. Yellow and orange is 7. Traces to here. Good. 8. Green and red traces back to here. Good. 9. This edge is oriented, good, which means we do not add anything. That makes our final number 9, which means our parity state is odd. Looking at this scramble, this is incredibly easy, and in 2 inner slice moves, which will leave our cube in an odd state, we can solve the entire first 2 centers. So we go 1, 2, and then we do a trigger. And that leaves our cube at odd. We can then solve this blue and white edge pretty easily. This white and red can be easily solved in the bottom here using 1 inner slice move. Our case is now even. This green and white is here and here. So we can do that using 1 inner slice move like this. It is now odd. And then I'm looking for either red or blue as I'm checking the bottom. And I see both blue, so since it is odd, I'm going to solve 1 inner slice move, setting up a double move like that, which will leave our cube in an even state and we won't get parity. Next, I would solve the orange on this center because all of the red is down here. We have a bar on the left, so we can just solve the orange and then cancel into solving this green in its correct spot, and then solve the final bar like that. And then we can solve the orange and white pretty easily like this. And then immediately I see blue and orange as I'm rotating. So we can start slicing back this way. The green and red needs to go here, and that's right here. So we can just put that in like that. The other edge is red and blue, which is here. So that solves both, and this one is already in here, so we can just unslice. Next, we could solve the green and orange like this. This does use 2 rotations, but that's okay. This green and orange is pretty easy to set up and then solve in the back like that. Orange and blue can be solved in the left by splitting it up and then inserting it. This green and red can then be solved in the back like this. And then we can rotate and solve this. And then in this case, I would probably insert like that. No parity, so we can do this OLL. And then we have PLL parity into a JPerm. Starting with tracing, the white and red is oriented, so our number begins at 0. White and green is here, so we can, before we do the RX2, we can just remain at 0. Green and red is here. It's oriented, so it's now 1. White and orange, it's still 1 because it's bad. White and red is our entire cycle, so we can start a second cycle. Picking yellow and orange, it's now 2 because it's a new cycle. Goes here. This is bad, so it stays at 2. Yellow and red goes here, it's good, so our number is now 3. White and blue is here, good, 4. Yellow, green, it's good, so it's 5. Green, orange is here, it's bad, so it's still 5. Blue and orange goes here, it's good, so it's now 6. Yellow and blue is here, that makes it 7, because yellow and blue is good. And then this solved edge back here is bad, so we have to add 1 to our found number, making it 8, which means the cube is in an even state. Looking around, we have probably the best way to do this is by solving the white and then doing a couple set moves to pair up the yellow bars. So we can do that by pairing up this with a trigger and then inserting with a double move. This doesn't change our parity state. And then we can do an L F prime, U wide, change it to odd, and that pairs up this bar and this bar. Insert with a trigger, doesn't change parity. Insert with a trigger, doesn't change parity. And then we can do a wide U prime like that. Next we have white and blue like that. Since it's odd, we can just do a double move, or leaving it at odd. I see white and orange immediately. This can be solved using one inner slice move, like that. That changes it to even. This white and red can then be solved immediately after using a double move, still even. I'm going to leave the red bar here, do a U prime on the green, and search for either the red or the green. I do see both, all four red, like here. So now I can, and since it's even, I can go 1, 2, getting no parity, and then solving green bar up top like this. And since I left the green bar down there, I can insert it and then cancel solving this blue like this, so that when we come back, it's solved. Move this solved edge out of the way, finish solving the orange, then inserting the green. This is pretty easy first 3 edges, because immediately I saw yellow and green. We can slice this way, put it in there. And the yellow and red is also easy. And the yellow and blue, it can also go there. So that is one rotation. And then the yellow and orange is also right here. So we can immediately insert it and see that the green orange is going to be right here. So we insert like this, do our slice, put the green orange in like that, leaving us with a 3 cycle. We can rotate over this way, do with lefty moves, insert green red, slice, insert like this, slice back. I saw green and orange pair, solve in the back right. And then I saw blue and orange, they can solve in the front left, like this. Blue red is free, rotate, solve the last pair, no parity, and then even cancel into solving this OLL like this. Then we have a G prime. Starting with tracing, this wing, red, blue, is bad, so our number begins at 1. Yellow, blue, here, it's good, so our number is now 2. White, blue goes here, it's good, 3. White, green, bad, still 3. Yellow, green, here, bad, so it's still 3. Green, red goes here, it's good, so our number is now 4. Yellow, red is here, it's bad, so our number is still 4. Green, orange is here, that's good, so our number is now 5. Blue, orange here, bad, still 5. White, orange goes here, it's oriented, good, so it's now 6. That completes our cycle. So then we do a second cycle because these 2 edges still haven't been traced through. So we can just pick white, red, and go 7. White, red goes here, this is bad, still 7. Yellow, orange goes here, it's bad, still 7. There are no solved edges anywhere, so our final number is 7, which means our parity state is odd. Looking at the scramble, I think, yeah, so we can solve this. We can solve yellow using 3 inner slice moves, which would leave it at even. So we can go 1 to pair up this and move these like this, and go 2, 3. Our cube is now even, so we can go ahead and solve using trigger and using another trigger. We can move over the white to the left, then solve this free pair on the bottom. This white-green can be solved in the back using 1, which will change it to odd. This white-orange can be solved using a double move, which will keep it at odd. And then I see this orange, and since there's no orange here, I know the orange, when I rotate this way, is going to be here. Since it's odd, we go 1 to make it even, and then insert it with a double trigger. Then we solve blue. There, we have 2 bars, solve them like this. And then we can do a U move to pair up both of the red bars, and then insert with a trigger. I don't see... Okay, so the white, blue, if I was here, I only see this one. So I'm going to rotate like that. And I see it here, so then I can insert it like this. And then finish solving here. I saw blue and orange, so that can be solved slicing to the right. Here. Green and orange can be solved here. The yellow and green is already solved here, so we can just slice back. Blue and red is here, so it goes there. Slice, yellow and orange. Then we can solve green and red in the front using lefty moves. Slice and insert yellow and blue, like that. We can then solve orange and green in the back, like this. And then keyhole this pair. Solve the corner. Blue and orange can be solved like this, which will set up red and blue for a 3-move insert in the back. We then have OLL and PLL parity into an ARP perm. Starting with tracing, this swing, orange and blue, is bad, so we start with 1. White and green is here, so we can immediately see it's good. And we have 2. Green and orange, we can find as we do our x2. It's here, bad, 2. White, blue, bad, still 2. Orange and blue is here. That's our first cycle. We can start our second cycle. This white and red is unsolved, so we go 3. This one goes here, good. It's now 4. Blue and red goes here. It is bad, so it's still 4. Yellow and orange is here, bad, still 4. Yellow, this was white and orange. Yellow and orange is here. This is good, so it's now 5. Yellow and blue is down here. It's good, so it's 6. That's an entire cycle, but we still have these 2 edges left to be traced. So we can go 7. This one goes back here, bad, still 7. This one comes back here, bad, still 7. So our final number is 7, and we need, which leaves the cube in an odd state. This is a pretty easy first 2 centers. We can do 3 set moves to a 2 inner slice move first 2 centers, which will leave the cube at odd after our first 2 centers are done. So we can go, after picking up the cube, we can go and then do 1, 2. Move the yellow over to the right, and we can solve white and green in the back using a double move, which will keep it at odd. White and orange was pretty easy like this, so we can just do that to make it even using 1 inner slice move. White and blue is right here, So we can solve it here using one inner slice move, which leaves the cube in an odd state. Then we can solve this orange center doing a double move, and then doing one move to make it even. We can then solve green right here. Start like this. Since we have a green bar on the left, we can just solve the green on the right. Solving the red over here. And noticing that in this case, we can actually cancel into solving our last cross edge. Because when we do this, instead of doing the last move, we can put the white-red cross piece here. And then finish doing our cross. Here I look at the blue and red as I do this. It's in the back. So I'm going to slice this way and then put the blue and red here. Do that like this. And then green and red goes here. And since the yellow and orange is then going to go down here, we can just do it with F moves like this and solve orange and yellow here. Next we have this 3-cycle. So yellow and green. Slice to solve it, and then the one that's orange and green is going to go down here. This case, I usually just put them next to each other and then do a 2-edge algorithm like this. I noticed orange and green edge and orange and green center corner here. So we can take out the edge and then solve in the back. Here we can actually just do, we can rotate to solve the red and green by doing an F prime, solve in the back, F, and then blue and orange can be solved like this. And then we can solve red and blue. We have this OLOL. And we have an E perm, but it has parity. So I would do this, see I have parity, do another one. Do my like that. Do U prime, parity.